So after learning about how to implement a particular multiplexer using logic gates, we will see how to use multiplexers to design combination circuits. So now on we'll be talking about, when we are talking about a multiplexer, we'll be talking about multiplexer ICs. Okay. So a multiplexer IC, say a 4 by 1 mux IC, it will be represented as an IC block. Yes, and you'll write the name of the mux inside it, 4 by 1 mux, and you will have 4 inputs, so those will be represented as 0, 1, 2 and 3 input lines. So these are the input lines and they are notated as 0, 1, 2 and 3. You will have 2 select lines, that is represented as S1 and S0, where S1 is the MSB, and you have an output line, and suppose the output is called as Y. Now let me just notate the input as I0, I1, I2 and I3. That is, I0 is the input given to the 0th line, I1 to the first line, I2 to the second line and I3 to the third line. So I0, I1, I2, I3 can be 0 or 1 each. So what we need is, how do we implement, say, suppose I'm getting a question like function of AB equal to sigma m zero, 1, 2. Yes. So what is, I want to implement this function, using a 4 by 1 mux. This is my question. Yes. So what does this particular equation mean? This equation means that if my input is 0, then my output is 1. If my input is 1, then my output is 1. And if my input is 2, then my output is 1. Now what I want to know is, what is A and B in the case of a 4 by 1 mux? They are the select inputs. Okay, instead of S1 and S0, I am notating it as A and B. So if I am to write the truth table of this, then I will write it as AB and my output is function of AB. So when I have 2 inputs, I can have 4 input combinations. These are my input combinations. And what will be my output? Output bit will be 1 for these particular inputs. So 0 means 0, 0. So for this, output is 1, 0, 1, output is 1, 1, 0, output is 1, and 1, 1, that is 3. 3 is not there in the list, so output is 0. So this is the truth table which I should get when I implement the circuit. So how do I implement this using this? So for that, first of all, I'll just change the names. That is, this is AB, notated as AB in the question. Okay, and this is function of AB, right? So when is function of AB equal to 1? When I give 0, 0, 0, 1 and 1, 0, my output should be 1. That is what is meant by this particular canonical form, and that we have represented using the truth table, and that's what we want from the circuit. So when I give 0 0, my output is 1. So in the case of a mux, when I give 0 0, what happens? What happens? I0 is selected and I0 will appear at the output. So if my output should be 1 when AB equal to 0 0, and when AB equal to 0 0, my I0 is selected and propagated to function of AB, then what should I0 be? That is, when AB equal to 0 0, then function of AB should be equal to 1. This is my question. Okay. But as per the mux, when AB is equal to 0 0, F equal to what? I0. F should be equal to 1. Here, in the case of mux, F is equal to I0. So what should I0 be? I0 should be 1. So I0 I will give as 1 or as logic 1. Yes, a high 5 volt in the case of digital circuits. Now if AB is equal to 0 1, then what should F be? I1. And according to our question, what should F be? Again 1. So what should you give to I0? Again I should give a logic 1. Yes. So I0 and I1 should be given a logic 1. Now when 1 0, again F function of AB should be 1. So I2 should also be given a 1. Now what is I3? I3 is 0. That is when AB equal to 1 1, my I3 will be selected, which should be 0, so that F of AB is 0. Now just check the circuit. If I check the circuit, I am giving 0 0 here. When I am giving 0 0 here, I0 is selected and whatever is there in I1 will come to function of AB. Now what is in I0? It is 1. So 1 will come here. Will any other inputs be selected? No. Only one input is selected at a time. So when AB is equal to 0 0, whatever is in I0, irrespective of whatever is there in other inputs, that does not affect the output. Only what is there in I0 affects the output. So I0 is equal to 1, so that 1 will come here. When it is 0 1, whatever is in I1, that is 1, that will come to the output. 1 0, whatever is there in I2 will come to output, and 1 1, I3 has a 0, so that 0 will come to output. So this is how you implement an SOP using a multiplexer IC. Yes. So likewise you can implement any SOP using a mux IC. This is the direct method. There are many complicated methods. This is one direct method. So you can try some questions. Yes, like implement function of ABC equal to sigma m, say 0 1 5 7, something like this. So from this question we should using a mux IC. Okay, they have not specified the name of the mux IC, just mux IC. Okay, so we have to decide on which is the mux IC since it's not given. So what should you see? function of ABC. So what are these ABC? What we say? These ABC are the select inputs. So you have 3 select inputs. When you have 3 select inputs, number of inputs equal to 2 raised to n, that is 2 raised to 3, that is 8. So the mux is 8 by 1 mux. Yes. So we will go for a 8 by 1 mux. So it will have 0, 1, 2, 3, 4, 5, 6 and 7. And I have my output. Yes. So what should I give to the inputs? My select inputs are A, B, C. You should write like this itself, whatever is here. So here A is the MSB, so A is the MSB. Right? So how will you connect the inputs? When select input is 0, 1, 5, 7, my output should be 1. So you can write the truth table. Then if you are to implement this using the 8 by 1 mux, then I have to connect these input lines 0, 1, 5, 7. 0, 1, 5 and 7 to what? Logic 1. Yes. And don't leave the rest unattended. You have to connect the missing numbers to 0. Only then will you get a 0 at the output when those inputs are selected. That is when 2, 3, 4, 6 is selected. In those cases you will get a 0 only if you connect a 1. Only if you connect a 0 to the input. Otherwise you can't predict as to what the output will be. It can be a 0 or a 1. Okay. So don't leave it floating. 2, 3, 4. So this is what we get. For these numbers you will give a 1 and the missing numbers you will give a 0. Now next is, how do you implement a mux, say a 4 by 1 mux using two 2 by 1 mux ICs. Okay, so this is what we should know. So for this we have to first know what we need and what do we have. So and an OR gate. Okay, so this is our question. So what do we need? We need a 4 by 1 mux. We need a 4 by 1 mux. And what do we have? We have 2 by 1 mux ICs and OR gate. This 2 numbers. So a 4 by 1 mux, what do we have in that? We have 4 inputs, 2 select inputs and 1 output. In 2 by 1 mux, single 2 by 1 mux, what do we have? We have 2 inputs, 1 select input. So 2 by 1 mux has 2 inputs, 1 select input and 1 output. So you have 2 such mux and you have an OR gate. So what I need, the truth table I need is this 01 I1, 10 I2 and 11 I3. So this is what I need. Now what do I have? I have two 2x1 mux ICs. So you have two input lines for each, one select line, one output line. Yes, this is what I have. Now let's check the truth table. What do we have here? When A is 0 and B is 0, I0 is selected. A is 0, B is 1, I1 is selected. A is 1, B is 0, I2 is selected. A is 1, B is 1, I3 is selected. Now in the case of mux ICs, we have another input which is called a control input. And this is called as a strobe, which is notated by G dash. Now, what is the strobe? Strobe activates a particular mux IC. That is, when this is notated as a G bar, that is, this is an active low signal. That is, this particular input is active when you give a low to it. Active when low. That is why it is notated with a G dash. So it is notated with a bubble and the name is G bar. Right? So the meaning of this strobe signal is, if you give a 0 to this G bar, this particular IC becomes active. That is, this will act as a normal multiplexer IC. If you give a 1 here, whatever be the input, whatever be the select input, you won't get anything at the output. This IC is off. IC will not work. That is when G bar is 1. Okay. So this bubble and this complement sign notates that it is active only if you give a 0 to that particular point. Okay. So keeping that in mind, here we can say that in these two cases A is 0 and in these two cases A is 1. When A is 0 and B is 0, then I0 is selected. A is 0 and B is 1, then I1 is selected. So suppose this is my I0. I am naming the second input as I1. Suppose this is my I2 and this is my I3. Okay, so that means that first IC, this is my first IC, this is my first IC, this is my second IC. First IC is selected when A is 0 and second IC is selected when A is 1. So how do you select an IC? By giving a 0 to the strobe signal. So when is the first IC selected? When A is equal to 0. So when A is equal to 0, G bar should be equal to 0 so that the first IC is selected. So what do? I will give that A here. So when I give A equal to 0, you will get a 0 here and this is selected. Right? Now, at that time, when A is equal to 0, this is selected. At that time, the second IC should not be selected, because if B is 0 in these two cases, so these two are my B. This is my B, this is my B. Okay, because in these two cases, B is either 0 or 1, 0 or 1. So, B can be the select line in both the cases. This is my B. Okay, I am just shorting the two select lines and I am giving the input as B. Right? So, when B is 0, here B is 0, here B is 0, here B0 means I0 will be selected and output will be I0. Here when B is 0, I2 will be selected and Y2 will be I2. So you don't want I0 and I2 to come as the output. You want only one, and that depends on whether A is 0 or 1. Whether you want I0 or I2 depends on whether you are giving A equal to 0 or 1. So if A is equal to 0, then the first IC should be selected. At that time, the second IC should not be selected. So what should be given to the second IC so that the second IC is not selected? A is 0, first IC should be selected. At that particular time, second IC should not be selected. So what should you give as the strobe to the second IC? A 1 should be given. So A 0 means you should give 1 here. How will you give? You will give a NOT gate so that the output of the NOT gate will be 1, and that is given to the second strobe signal. Yes. So if we see here, when A is 0, this particular IC is selected. Here you get a 1. This particular IC does not work. And A is 0 means this IC is selected. B 0 means I0 comes here. B1 means I1 comes here. A1 means here it is 0. That is the second IC is selected. First IC is not there. So B0 means I2 will come to Y2 and I3 will come to Y2. Now the another problem is that for a 4x1 mux, you have only one output. But since you are using two 2x1 mux ICs, you have two outputs. But you need only one output. So what is that output? That output should be either the output of the first IC or the output of the second IC, because both Y1 and Y2 will not be active at the same time, because only one IC is selected at a particular time using this. So either Y1 or Y2 means you are giving this to a OR gate. So this is your Y. Okay. So A0, B0 means this IC is selected, I0 comes here. Here there is nothing. So that I0 comes to Y. A0, B1 means I1 comes to Y1 and that comes to output. A1, B0 means A1 means first IC is not selected, second IC is selected, and I2 is selected to Y2. There is nothing in Y1. A1, B1 means first IC is not there, second IC is selected, I3 is selected to Y2 and Y is equal to Y2. Yes, so that is how you implement a 4x1 mux using two 2x1 mux ICs and an OR gate.